slides itself. Okay, so it is about exponent today. Exponential notations denotes multiplying the same number by itself many times. Usually we can see some of that numbers is multiplied many times by itself. Okay, that is 3, again it is multiplied by 3, again it is multiplied by 3. It goes like that. So this kind of structures, a number structures, is called as exponent. Okay, so it is useful in daily life. Yes. How? Usually we are having the formula for square area of a square is a square. That is, if a side of a square is having the length of 3, suppose that area of the square is nothing but 3 square. That is, it is denoted by the square units. So it is one of the useful thing about the exponent. It is the structure of the exponent is like that. That is a power n, where a is called as base and n is called as index or exponent, where a is can be a real number, a can be a real number and n can be an integers. Okay, so that the positive and negative numbers also comes in that place. Okay, let's see some more things about that structure. Usually a power n denotes a into a up to n times. That is, a was repeated for n times, so that it is called as a power n. A power 0 is usually called as 1 here, and a power minus n is equal to 1 by a power n. Usually we are using this notation. Next, we are going to know about the exponent laws, which makes working with that exponent number easier. Usually, sub a power n into a power n is gives that a power m plus n. Let's see an example about that. Suppose we are having 2 and its power is suppose 3 power x, 3x. Okay, and we are multiplying this 2 into 2 the whole power 4x. Okay, so we will have the answer for this is 2 power 7x itself. That is 3x plus 4x. I will write it in this side. That is 2 power 3x plus 4x. It will give 7x this answer. Okay, so we will go to the more laws here. Okay, suppose I using the second one is a power m by a power n is equal to a power n minus m. So that is, I am going to use the same number here. Suppose 2 power 3x by 2 to the power 4x here, 2 to the power 4x here. It will use what? 2 to the power 3x minus 4x, that is 2 to the power minus 6. Okay, by that usually it is denoted as what? 1 by 2 power x. It is the way we has to represent that. Okay, next, ab the whole power n, it is nothing but a power n dot b power n. So let's have some more example about that. That is 6 square, that is 2 into 3 the whole power 2. You can represent that as 2 power 2 and 3 power 2. What is that? 2 power 2 is 4 and 3 power 2 is 9. So here also we are having 36. Okay, so by this also we are having 36. We can use any numbers, any real numbers, so that it can be verified easily. This law can be verified easily. Next one is a power m into n is equal to a power mn. So this also can be verified very easily. Next, we are going to simplify this exponent sum. Okay, let's take this sum 2 power t minus 2 power t minus 2 by 3 into 2 power t minus 2 power t. Let's do this sum by one by one by steps. First I am going to do is I am going to split the exponent term, that is 2 power t minus, this time I am going to split this one. Okay, it is 2 power t into 2 power minus 2. Okay, by 3 into 2 power t minus of 2 power t. So I am going to take that 2 power t outside. 2 power t is taken as common now. Then it will be 1 minus 2 power minus 2 by 2 power t into 3 minus 1, taking that 2 power t as common. Now we can cut this both of the things, right? That is 2 power t and 2 power t will be cancelled. So we will have the result as, next step as 1 minus, it can be written as 1 by 2 power 2, right? And the whole by 3 minus 1 is nothing but 2 here. Okay, right. Let's go to the next step here. That is 1 minus 1 by 4 here by 2. Okay, that is nothing but 1 minus 1 by 4. Okay, we can do the sums like that, 4 minus 1 by 4, the whole bar by 2. Okay, this can be done. Otherwise we can say like that, 1 minus, it is quarter is that is 3 by 4th, we know that, right? So the next step will be 3 by 4 by 2 by 1. Okay, so we can take go into the reciprocal, that is 3 by 4 into 1 by 2. So that answer will be 3 by 8. So we solve this sum also. Okay, let's have a recap among all these things. Okay, first we got start with that, what is exponent first, and give some examples about that exponent. Later we are having the structure of that exponent. After that we are having a laws, some exponent laws here. So I simplified some only one problem, very easy problem with using the exponent laws. Thank you.